Hi, Assalamualaikum. Okay, guys, as usual, don't forget. Also, okay, thank you. Okay, guys, so let's continue the topic by resistors. Okay, as we know, there are two different type of arrangement of resistors, which is in series, also in parallel. Okay, so seems like we have learned everything before about the capacitor, which is arranged in series and parallel. Okay, so the concept here is still the same, but I think we have a little bit different between resistors and capacitors. Okay, so let's start by the resistors, which is arranged in series. Okay, guys, so this is the example of resistor which is arranged in series. There are three resistors now, which is R1, R2 and R3 arranged in series. Okay, how do you know that these three resistors just arranged in series? Okay, because seems like this is I total produced by the cell, and then I total just pass through R1, R2 and R3, isn't it? There is no junction, can? Okay, so that the current through each resistor now still the same, which is I. So without any junction, or when the current just pass through each resistor just equal to each other, means that they are arranged in series. Okay, so for this, as we know, I through R1 is I1, I through R2 is I2, and I through R3 is I3. At this time, each I equal to each other, so I1 equals to I2 equals to I3 equals to I total. So this is the first info do we have. Okay, and then for the second one, all right, so this is VT. VT is V total, which is the potential supplied by the cell. At the same time, when the current just pass through R1, so what do we have? V1 equals to I1 R1, isn't it? So V1 representing the potential drop or the potential used by the first resistor, while V2 is the potential drop or used by the second resistor, and V3 is the potential drop or used by the third resistor. So in this case, V1, V2 and V3 is V drop or V used by each resistor, so that V1 plus V2 plus V3 equals to V supplied, which is V total. So V total equals to V1 plus V2 plus V3. Okay, from this we know that V total equals to I total R total or R equivalent. So remember, R equivalent still equals to I total equals to V1. V1 is I1 R1, V2 is I2 R2, and V3 is I3 R3. So I1 R1, I2 R2, I3 R3. But remember, I1, I2 and I3 equal to each other. We take it as I, which is I total, isn't it? So substitute here and then you will get this equation. So I total, I total, I total, I total, cancelling each other, giving you R total or R equivalent equals to R1 plus R2 plus R3. Okay, so remember, in series arrangement, the current just equal to each other, and then the total potential supply equal to the potential drop by each resistors. So it's quite different here between capacitors and resistor. For capacitor in series, to calculate C total, it must be 1 over C, isn't it? 1 over C total equals 1 over C1 plus 1 over C2. But now for the resistor, we just total up the values directly, which is R1 plus R2 plus R3 equals to R total. Okay, alright, that one for series arrangement. Okay, how about the parallel arrangement? Okay, now please refer to the diagram given now. So still the same, there are three different resistors, which is R1, R2 and R3 arranged in parallel. How do we know? Okay, so this is the power supply giving you I total. So I total just pass through the wire, reach the junction, separated to be I1, separated to be I2, separated to be I3. Seems like the current just separated here, isn't it? So by having different currents means that these three resistors just arranged in parallel. Okay, because the current just separate here. Alright, so in this case, they are arranged in parallel. So remember, for any parallel arrangement, the potential just equal to each other. Okay, so again, this is V total, which is V supplied by the cell. This is V1, V across R1, which is V drop by R1 or V used by R1. V2 V drop by R2, or V across R2, or V used by R2, and V3 V across R3, or V drop by R3, or V used by R3. Okay, so remember V drop here, they are arranged in parallel, so the potential should be the same lah. So V1 equals to V2 equals to V3 equals to V total. Alright, how about the current? Okay, remember the current just separated at this junction to be I1, I2 and I3, isn't it? So I1 plus I2 plus I3 giving you I total. So this is the second equation. Okay, from this equation, as we know, V equals to IR. Wait, let me write for you. V equals to IR, so that I equals to V over R. From this equation, we just expand the equation now. I1 to be V1 over R1, I2 is V2 over R2, I3 is V3 over R3, and then you will get this. But remember, V1, V2 and V3 equal to each other, which is equal to V total, isn't it? So we just substitute by V total, V total, V total, okay, equals to, this is I total. I total is V total over R total, or equivalent R lah. Okay, so V total, V total, V total and V total, they are cancelling each other, giving you the equation to be like this. Okay, so this is the way how do we calculate R total or equivalent R lah. For any parallel arrangement, it must be 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so it's quite different compared to the capacitor. For any capacitors which is arranged in parallel, to calculate C total, it must be C1 plus C2 plus C3, isn't it? But for the resistor, it's quite different. So don't be confused for that. Okay. Okay, so let's discuss one example for this subtopic. Alright, so please refer to example 3.10. Okay, there are three different resistors, which is R1, R2 and R3. So R2 and R3 just arranged in parallel. How do we know? Because we got junction, this is the current, total current, I total. I total just passed through R1 and then reach this junction, separated to be I2 and I3, isn't it? And then the current just reached the junction again, so I2 and I3 combined together, producing I total back. See? So seems like you got junction here, so R2 and R3 just arranged in parallel. Okay, so become one, R23 and R1 just arranged in series at last. Okay, so this is the way how do we combine the resistors. Okay, so by giving you R1 as 2 ohms, R2 as 12 ohms and R3 as 4 ohms, so they ask you to calculate the total resistance of the circuit, the total current in the circuit, and the potential difference across 4 ohms resistor. So 4 ohms resistor is R3. They ask you to find V3. Okay, so how is it? This is the way how to answer the question. Okay, so as I told you before, alright, so this is I total. This is I total. I total. We take it I total only. I also I. Okay. Alright, so first they ask you to calculate the equivalent resistance. Okay, so we need to combine these two first, R2 and R3, which is arranged in parallel, isn't it? So 1 over R23 equals to 1 over R2 plus 1 over R3. Okay, so substitute all the values and then you will get the answer, which is R23 getting out is 3 ohms. So now we just have the circuit to be like this. Alright, so this is the cell. Okay, so this is R1 and this is R23, which is combined already to be 3 ohms. So R23 and R1 just arranged in series. So to calculate R total, it must be R total or R equivalent equals to R1 plus R23. R1 plus R23, which is R1 equals to 2 and R3 getting out is 3. Okay, total up you will get 5 ohms. Okay, so this is the way how do we combine the resistor step by step. Alright, and then they ask you to calculate I total. So I total equals to V total over R total. V total given out is 6 volt and then R total getting out is 5 ohms, giving you 1.2 amperes. So see, normally question B just relate to questions A lah. So by getting wrong for A, of course B also wrong. So be careful in answering that question, okay? Alright, and lastly, they ask you to calculate the potential difference across 4 ohms resistor. So they ask you to find V drop by this resistor, which is V3 lah. So how is it? First, we know that the current through here is I total, isn't it? So by knowing the current here, we may calculate V1. Okay, so we just calculate V1 first. V1 equals to I total R1, so that you will get the potential drop here is 2.4. As we know, 1, 2, let me draw first. Sorry, this is R1 and this is R23. So R1 and R23 just arrange in series, isn't it? So that we know that V total equals to V1 plus V23. Okay, so V total given already, which is 6 volt. V1 calculated just now. This is V1. So that you will get V23. Okay, by getting V23, as we know, 2 and 3 just arrange in parallel. So V2 equals to V3 equals to V23, isn't it? So to calculate V3, we need to calculate V23 first. So V total equals to V1 plus V23. So V total is 6. V1 getting is 2.4. And then you will get V23. V23 now getting is 3.6, which is equals to V2 equals to V3. So that we have answered the question. They ask you to calculate V3, isn't it? Alright, so this is the way how to understand the question, and how do we answer the question step by step. Okay, I hope it's very, very clear for you. Okay. Okay, how to calculate R total for this question? Okay, I think there are so many R given. 1, 2, 3, 4, 5. Okay, any suggestion how to answer the question? Okay, so let me explain you lah. Okay, normally we just start by combining these two R first. Become 1. They are arranged in series because there is no junctions in it. Okay, become 1, and then this resistor just arranged in parallel with this, because we got junction here and here, isn't it? Okay, so in parallel should be 1 over R plus 1 over R. Before this, R plus R giving you R here. So R here now and R here, they are arranged in parallel, should be 1 over R plus 1 over R, giving you 1 R. And then 1 R here now, just arrange in series with this, isn't it? So again, R plus R, giving you R total here. And then lastly, by getting 1 R there, they are arranged in parallel. Okay, so this is the way how do we answer the question. Okay, so I think you need to try to answer the question. Okay, bye. Assalamualaikum.